Well, hello again everybody, and as you can see I've got a mystery package. Well, I call it a mystery package. I've actually got no idea what's inside it, but I've got a pretty good idea where it's come from because it's got this very telltale orange tape on it. So I know that this actual package, it's actually come from Benji.
Hi, and welcome to Foxy's Den. I just thought we might talk about audio cables. It would seem there's many out there that would seem to think that you need to spend obscene amounts of money on what is simply just an audio interconnect. Well, here's my thoughts on the subject, having worked in the industry making audio cables in one. As I say, I'd like to show you this working at the moment, but unfortunately I don't have enough D-cell batteries at the moment. They cost an absolute fortune.
So let's go ahead and let's have a look at what Benji sent us. Oh, we've got a letter. So here's the accompanying letter that Benji sent to us, and of course you can see at the bottom it's got his trademark Little Fox. So he says in his letter that he's actually sent me a few bits and pieces to have a look at. Wow, so we've got a plastic dinosaur, and it's actually a money box. Now, I'm not exactly sure what this has come from, this. I don't know if it is something to do with, I don't know, fuel products, or was it a giveaway from gas stations or something like that? Let me just double check what Benji said in his letter. Okay, I see, said the blind man. So what Benji was actually saying in his letter is that he's decided to send me this dinosaur because it was missing its friend on the sign here. And you can actually see that they're a pretty good match, aren't they? They actually look exactly the same. I wonder if this was actually related to the Pennsylvania Motor Oil Company. Was this a branded article? Sorry, was this a branded item which they actually manufactured? I've got absolutely no idea. Is he a Brontosaurus or a Diplodocus? I've really got no idea. Can any of you dinosaur experts, dinosaur aficionados, can we actually identify him? And I wonder if he's got a name. I'll have to ask Benji if he's got a name. Anyway, thank you very much for that, Benji. He's very cool. And I will put him together with the sign, and he will be on display, and I'm sure you'll see him again in future episodes, I think. Well, we've got lots of good stuff in here to go at. Let's see what we've got next. Oh, cool. Are they lights or LEDs or neons? Just wondering what voltage bulb we've got here. Well, this bulb does actually have some writing on it, but I can't actually see what voltage it says. I just can't read it. Let's try reassembling it, and what we'll do is we'll put some power on it. So that's quite interesting. When you try to reassemble this bulb into the holder, it kind of it pushes back. It's in some kind of spring-loaded assembly. I really like the colouring of this little red lens. They're much more pleasing to the eye than modern LEDs, aren't they? Oops, he said it fell apart. Come on, stop being so cack-handed. So I'm just having a close look at this to see if we can see the manufacturer's name on it, but it doesn't appear to have anything. Maybe Benji will leave it in the comments, tell us where he salvaged these from. I wonder what the voltage of that should be. 12 volts. That actually looks a bit dim to me, but that'd be okay. Should we go a bit more? Okay, that's 24 volts. I'm thinking that maybe that's a 24 volt bulb. That looks about right to me. Or do we think that's too bright? I'm not sure. I'm going to go for that being a 24 volt bulb. So I've just been rooting through my bulb collection. I've just found a pack of these bulbs which I think will fit, but I can see that on the side of these are 12 volt bulbs. So these say 6, 7, 9, 12 volts. Again, not sure what style they are. Somebody will leave it in the comments, won't they? Are these something like Les or Mez? I'm not sure. Just wondering if I've got any lamp holders in my little collection here of salvaged items the same. That's quite a nice one, isn't it? That's obviously something I've salvaged from a piece of test gear. This obviously takes a a screw-in bulb. This actually looks a lot like the lamp that was on the front of that Taylor signal generator we were looking at previously. In fact, I think it's the same style. It had a lamp holder like that and a little red lens. I've got various, I think these are neon indicators that I bought new for projects. That's quite a pretty lamp holder, isn't it? Again, I think that's got one of them little screw-in bulbs. Now also in my lamp collection I've just found these old bulbs and this plastic holder, and do you remember, I think these were the kind of holders that you would have inside something like your old Austin Allegro, the dashboard for the handbrake parking lamp or the indicators, and yeah, they were always swines to get, and they used to fail constantly, didn't they? And they used to make pretty poor contact because it doesn't have a proper base on it. The bulb just has some bent over wires, filament wires poking out the bottom. So the idea was you had to push them into these holders and something like that. But yeah, they weren't very good from memory. Quite often keep things like these 12-volt bulbs. These are something like indicator bulbs off a car. They're handy when you're working on DC circuits. Again, you've seen the big version of lamp limiters that we use for working on mains AC, but quite often when you look at working on smaller DC circuits, it's still useful to have these lamp limiters. So here's a 12-volt bulb that I've just put some wires on to protect some other piece of equipment in the past that I've been playing with. Well, even found some Christmas tree lamps. They were a bit late to the party, weren't they? Okay, let's go for the next one. So the next two items that I've got to look at is two valves, and well, let's have a look at them. The first one here, this one's made by Mullard, and the other one is made by Mullard as well. Now, just taking a look at these, I can see some little marks on the legs on the pins sticking out at the bottom, but looking at the glass envelope, I'm pretty sure that these have never been used. So the number on this one, it's a 30 PL13, and then underneath it it's got PCL 800, and of course it's made in Great Britain. So just looking at this valve, it does appear to be absolutely brand new, and I'm sure you'll agree that there's something really quite beautiful, almost architectural about valves. I mean, just a lot more interesting than solid state devices. More interesting, much more glamorous. So we've got a 30 PL13. Now apparently what we've got here is it's a triode beam tetrode, and these are used in the frame output stage of a television set. So the second valve we've got here is another Mullard valve, and it's a PCF80. Now apparently a PCF80, it's a VHF video amplifier valve, and it's a cathode follower. And again, I'm afraid I really can't tell you very much about this because I'm still learning about television sets, but just looking at the condition of it, it's no burning on the envelope, so I'm pretty sure that this is a brand new valve and it's never been used. So thank you very much, Benji. Oh, look at that. Does anybody recognise that? You would have seen something very much like this inside the that frequency counter, timer counter that Benji sent us. He did say in one of the comments that he left that he'd got a box of these somewhere. So I can see that this isn't a valve in the conventional sense. It's actually a crystal oscillator unit, and it's got the frequency stamped on it, which is 145.8 kilocycles, and again, just like the one that was in the timer counter that Benji sent us, this one was manufactured by GEC. I'm not sure if any of them is a date code. Not sure. 1634-9, and of course made in England. Now the interesting thing about these, I don't know if the camera will zoom in, but you can actually see that they've actually got an enormous slab of quartz in them, because people talk about crystal oscillators and they actually have a slab of quartz inside them, and in this one you can quite clearly see the slab of quartz. Just notice that this valve has this stamp on the bottom of the box. Is that the old Granada TV symbol? Now, I've got to admit, I find these old branded packaging really quite evocative of a lost age, basically. So we've got a lovely yellow and kind of reddy orange box with the Tumsgram brand on it, Tumsgram valve. Apparently back in the day this cost 50 pence. Oh yeah, and this is an EY87, or is it an EY86? Not exactly sure. Yeah, EY87. Again, another brand spanking new valve. Again, I can tell just by looking at this valve that it's never been used. It looks quite simple, and it looks of really quite heavy construction. So is this something like a rectifier valve? I think it probably is with that prefix EY87. Let's just look it up. So I've just gone ahead and looked this up, and I'm just looking at the separation between some of the electrodes, and now I've looked up the valve data, it kind of makes more sense. So this EY87 valve, it's actually classed as a high voltage rectifier, and it says that the maximum voltage is actually 18 kilovolts. So 18,000 volts this thing can rectify. Wow, that's amazing, isn't it? Again, I don't think this one's been used either. So I was just saying that Benji's really done us proud, because I am planning on restoring a television. It's actually at work at the moment, the television that I'm going to work on. I'm still trying to find, I have something that they call a standard converter that converts from, I think it's composite video or something like that, into the 405 line television standard, and I actually purchased one of these quite a few years ago, the last time I had a vintage television, and I put this converter, this standard converter, somewhere safe, and it's so safe that I haven't managed to find it. It's one of them things that every now and again I kind of find it and put my hand on it and think, oh, I must keep hold of that, and then it disappears back into the hoard, not to be seen for a couple of years. So I'm searching for this standard converter, and as soon as I've managed to find it, we'll get cracking on the television restoration, because I don't really see that there's a lot of point in doing a television unless we can actually see a picture on it at the end. So I just found another item that Benji sent us, and this looks as though it's not a valve. So let's see what this one is. Now, I'm not sure, are they buzzers, or I don't think they'd be speakers. I think these are maybe some kind of buzzer, but I'm not exactly sure. Got a metal diaphragm on them. Well, just looking at the label on the back of these are manufactured by a company called Kirk Acoustic, but I'm not exactly sure what they are. I'm going to go for a buzzer, because I can't see that we could get a fidelity sound out of these, because they've got like a metal diaphragm on them, so I think it must be some form of buzzer or sounder. Now, I'm sure if you watch my channel you also watch Graham, the Radiocruncher's channel. Now, a few weeks ago Graham was actually working on a 13.8 volt power supply, the kind of thing that you would use on a CB radio, and that reminded me that I actually have a very similar power supply myself. Now, I actually bought this power supply at a ham radio rally, and when I actually bought it, which is quite a few years ago now, I think I paid something ridiculous for it, like £2, and it was actually brand new in a box and in perfect condition then. And to be honest, I'd had better power supplies, more powerful ones, so I didn't actually make use of it. It kind of just sat in the back of stores for a long time. And then one of my friends at work said, can I borrow the power supply? I think he wanted to do something like, he had a car radio in his bedroom, and he wanted to use the car radio inside for some reason. So I lent him this power supply, and I think he had it a little while, and then he brought it back into work and said, unfortunately it started smoking, and it doesn't work anymore. So I don't exactly know what he's done to it. When it came back to me, the screws had already been taken out, so I've got no idea what's wrong with it. It could just be a blown fuse, I've got no idea. I did notice that it's got some bent in corners, so I think it might have been dropped at some point as well. Now, I think as far as cheap power supplies go, there's nothing particularly wrong with the Altai brand. I certainly remember having an Altai variable power supply when I started in electronics many years ago. You know, they're not top quality, but they're kind of workable, they're okay. Just taking a look at this one, see it's got it's got some built-in safety precautions. They've put a plastic cover. I don't know if that should be screwed on, but at least it has got a protective cover to protect you from, well, I'm guessing this is relatively low voltage. This is obviously a circuit board here that's got the DC controls on it, and I can see we've got a regulator. Is that a regulator? No, 2N3055. So we've just got a large pass transistor at the back, the famous 2N3055. So hopefully we'll find one of them in the junk pile. Looks as though, yeah, it's definitely been dropped, hasn't it? Because the the actual transformer is kind of bent over at somewhat of a jaunty angle. So yeah, the base plate is bent. So we might take the transformer off later and see if we can straighten that out, shall we? Do you want to place your bets? Is it going to power up? Is it going to explode? Is it going to smoke? I've got no idea. So well, let's throw caution to the wind, eh? Okay, that's on. Oh, lights up, so we've got mains voltage. Let's just unplug it. Let's check what the output is. Well, today I'm using this Ryobi meter, which I don't particularly like very much. The reason I'm using it is for the simple reason I can't find my fluke meter. My office is in a mess, and I put it down somewhere and I can't find it. So we're using the Ryobi. So if we're getting the output voltage, okay, that's floating around madly. Let's just check that we haven't got any AC on there. No, we haven't. Let's just go. The next port of call I think we'll go to is the pass transistor. Okay, I've got 24 volts on one side of it. Got 14 volts on the base. And we've got nothing on the third leg, on the emitter. So I guess my very quick diagnosis is that our output pass transistor there has died. So I think the first thing we'll do is we'll put a transistor tester on it and see if that's the case. Right, so that's only coming up as a forward biased junction, so it's looking like a diode, that thing. Now I've got to admit that is quite a large power transistor. I'm not exactly sure what they should look like, so I think what we will do is we'll try and just get another of these power transistors, which is it's a Toshiba 2N3055, very common output transistor. Let me see if I can find another one, and we'll just check that on the analyzer and see what it comes up as. Right, that is coming up as an NPN transistor, which is correct for a 3055. And what we'll do is we will just go down, and I'm guessing it's going to be 74. So this is a big power transistor, so it's not going to be very high gain. 74 is probably in the ballpark for it. Just double check the number on it. Yep, 2N3055. And I think when we've actually disconnected this, I will test this transistor again when it's all been undone, and we'll test it separately on the bench. So these type of transistors, they are, as you can see, they're actually screw mounted. And one of the tabs, the body on the transistor, is actually live. So when you actually mess with these, you'll see that it comes with a little, I call it an insulating top hat here. So it's very important that you put the insulators back in the right place, or you will end up shorting out the output from the power supply, and again that can really ruin your day. So we should also find a big mica insulating washer when we pull the transistor off as well. Which we have, but interestingly enough there's actually no thermal compound on here, which I do think is that's a little bit lacking, isn't it? I wonder why they didn't bother putting a thermal compound on. That is not so good. So just taking a close look at the transistor that we've removed, it is a Toshiba made transistor, a 2N3055, made in Japan, so you know, a very good quality transistor. I wouldn't have thought that thing would just expire for fun. The transistor that I've got here to replace it with, which is another 2N3055, and it does look very, very similar, but it's got a slightly different case. This one looks to be, I don't know, IPS. I don't necessarily know what IPS stands for. I wonder if I've got any original Toshiba transistors. I might see if I've got another Toshiba just to put the same transistor back, but these are kind of jelly bean parts. Now, of course, if you've worked on power supplies before, you'll already know this. Power transistors do just blow up for fun. Any component that gets hot or has got power running through it, you've always got to consider that as being a failure point in any circuit. So just as a kind of rule of thumb, when you're trying to diagnose an amplifier or a power supply in this case, it's quite often worth going to the components that get hot first. Anything that gets hot will be electrically stressed and is more prone to failure. And I suspect what's happened here is this is actually just somebody's been using this just to draw too much power, and they've actually overheated the transistor and burnt it out. Now we're taking it out of circuit, let's double check it again. Amazingly enough, it hasn't got better of its own accord in the last 10 minutes, and it is still coming up as just a junction, a diode junction, so that is no good. So the transistor that we took off, even though it had quite a substantial heatsink here, they hadn't bothered to put any heatsink compound on it, which I do think is a little bit surprising, but I am going to put it back with some compound. I'm just going to give our little mylar insulated washer a bit of a clean, because you don't want any little bits of grit or anything on there that's going to stand proud and stop the transistor making good thermal contact. So just giving that a wipe. Okay, that should be clean. And just going to put some gunge onto our transistor here. I'm not a massive believer. Some people put absolutely loads of thermal compound off. I think if anything that's a bad thing to do, because it actually holds the transistor off. And then you tighten the screws down, and over a period of time the thermal compound leaks out and it leaves a gap in its place, which is not a good thermal conductor. If anything, I think I've probably put a bit much on there, but c'est la vie. And I'm hoping that this transistor is going to go kind of the same way up as the other one did. And we mustn't forget our top hat washers. And I think we also had a little capacitor on there, which is that's just designed to stop this transistor going into oscillation, because it's got quite long wires on it, so that goes between the base and the emitter. Now I often think the best way to tighten these up is, what you want to do is you want to go ahead and you want to nip them up both sides, and then what you actually want to do is you want to run the piece of equipment for a little bit, because that thermal paste will get hot, it will go a bit thinner and it will run and settle down. And then when you have run it maybe for a couple of days, a piece of equipment, keep an eye on it, just come back and maybe tighten up the transistor again, because you'll find if you do that it will just seat better. Now obviously you can't always do that if you've got to get the repair out the door, but if you can do it, I do think it is worth doing. Okay, so that should be good now. Might just clean off a little bit of this heatsink compound. And with probably around a 1 amp, 1.5 amp load on, we're getting 13.86 volts. We could adjust that down to dead on 13.8, but I think that's quite good enough, so we will leave it at that. Shall we try it on a proper DC load? We may as well. Let's see if it actually will output 5 amps. It just does claim here that this thing will output a constant 5 amps, so let's see if it's being truthful or not. Well, as you can see, I've gone ahead and I've just dug out my rather vintage Kirkasui load. And for any Kirkasui fanboys out there, it's a model number PLZ 300W. So it's a 300 watt electronic load. Let's switch this on. It is rather deafening. It's got an enormous fan inside, which is quite capable of sucking up small animals and children. So what I think we'll do is we'll just wind the load up until it gets to its full rated current, which in this case is about 5 amps. So this one is the ampage here, which is 1 amp at the moment, and this is the output voltage coming from the power supply. Now this voltage will actually end up being a little bit less because of the resistance of these leads. So let's wind it up all the way till we get to about 5 amps. Oops, went past it a bit there. Okay, 5 amps. What I think we'll do now is let's just see if it will do a rated 5 amps constantly. It does claim to on the instructions here, so I'm going to go away. I'm going to leave this running for about an hour, and we'll keep an eye on the temperature of the heatsink, and I'll bring you back when we've done that. Well, it's about an hour later, and I'm pleased to report that the temperature of this heatsink now, it's quite hot, and I'm guessing that this pass transistor is around, I don't know, around 60 degrees, so it can run all day at that. And actually the heatsink itself is actually a similar temperature. It doesn't feel too different, the temperature of the heatsink, to that of the transistor. So that means that actually the transistor is managing to dump all its thermal load into this heatsink, so no problem there. Now, of course, you don't really need to worry about these pass transistors getting hot. They are actually designed to get hot. Heatsinks are designed to get hot. The fact that I can just about touch it without my finger kind of sticking to it, that means it's running at a good temperature. And of course this thing is actually running now at its maximum constant, which is for this unit is 5 amps. Now it says it can also take a surge of 7 amps, so I'm quite tempted to actually try that actually. Okay, 7.1 amps, and well, in theory it shouldn't blow up, so let's do a surge. Okay, it's had some 7 amp surges. Let's go back to its 5 amp output. And check it still works. Which it does, so all is good. Well, I'm sure that you'll agree that was a very non-taxing repair, wasn't it? Nothing particularly complicated, just a very simple Altai power supply that had a burnt out output transistor. So I think for today that will do. And as always, thanks very much for joining me, and I hope to see you again very soon. But until then, bye bye for now.